In this tutorial, we'll look at an introduction to cryptography. One of the first uses of cryptography comes from Julius Caesar. And Julius Caesar wanted to send a message to his troops in battle. And so he used messengers to do that. So let's suppose Julius Caesar wants to send a message. There are two problems here. He doesn't want the message to really be read by the messenger, perhaps could take that message to the enemy, but he also doesn't want it changed. He doesn't want to get the wrong message to the troops. So Julius Caesar used one of the earliest encryption systems. We call that the Caesar cipher, where letters of the alphabet were substituted for other letters. So you may take every letter of the alphabet and just sort of rotate it 4 positions to the left, and you get out something different. So you may put in DEF, and so this is the message that can be read, for instance, attack. And this is called plain text because it can be read by everyone. And we have a little encrypting algorithm, and out pops ciphertext. So we would get, if we put it through this algorithm, out would pop this, and this is called the ciphertext. Now, who would know the algorithm? Well, his generals in battle would know the algorithm, and of course Julius Caesar would know the algorithm. So the message is encrypted and given to the messenger. The messenger can't read it. It doesn't make any sense. The messenger gives it to the general, who then decrypts the message and passes it along to the troop. So there's one reason why you might want to encrypt information, so that A, it is not read because it may be private information, and you don't want it changed. So let's look at a couple systems which are widely used in digital systems to encrypt information. So we'll look at this basic encryption system here, where we have some information here, which we'll call our plain text. And since we're working with computers, all information is basically just a series of numbers. Now we apply some algorithm to these bunch of numbers with what we call a key. And a key is just, again, it's another long number of so many bits. And in the system that we're going to show here, this might be 128 to say 256 bit key. So we take the plain text, or basically the series of numbers here, and we apply an algorithm to encrypt the information. And the algorithms that were invented are all based on prime numbers. We're not going to go over the details of the math involved and how this all works. But basically we have a plain text information. We're going to apply an algorithm to it which is going to encrypt or encode the information so it can't be read. And you can think of this as having the information and it's being locked. No matter who has the information, they can't read it. Okay, so now we have this encoded information, or what we'll call the ciphertext. Let's suppose someone at another place wants to read what's inside here, that is, get the plain text out. Well, they can apply the same key, okay, that they have here, and all of a sudden out pops the plain text if you apply the proper algorithm. Now, when you have an encryption system which encrypts and decodes, so this is going to decrypt the information here, and you use the same key, it is called symmetric. Symmetric key encryption, because you're using exactly the same key. And this is very fast. In fact, symmetric key encryption systems are what are used today in the bulk of our digital communications. One of the most common symmetric key systems that in use is something called AES. And it's one of the more secure or most secure systems in use today. So the keys here, we have key concepts here, that of plain text and ciphertext, the fact that we have a key. Symmetric key encryption uses the same key to encrypt and decrypt the information. The encrypting algorithm, or sometimes it's called the encryption protocol, because it's when you encrypt and decrypt, it's more than just one process. There are a series of processes which are used. And the one we're using here, or as an example, could be an AES. That's an encryption protocol. And because we use a single key to encrypt and decrypt, sometimes that key is called a shared secret. So the key here is that both people have to have the same key. Now there is a problem here in key distribution, which we'll look at. Because how do you get the key to a remote person if you can't actually travel and give them the special number? And that's what happens today, because we communicate all over the world. It's not possible to travel and distribute keys around the world physically. So that's the first encryption system we'll look at. The next encryption system that we're going to look at is called public key encryption. And it works this way. There are actually two keys that are used in the system. We'll call this one the public key, even though it looks like a lock, it's actually a key that's used in an algorithm. And this one we'll call the private key. Now, public keys are distributed to the general public. So if I'm a person and I want information sent to me and I want to make sure that it's encoded, I send out my public key to basically anyone who I want to send information to me. So we have some plain text here, and I have someone who wants to send me information. So I've sent that person my public key. The plain text is then encrypted using the public key. And what we get here is ciphertext. So anyone who might intercept this information, it's garbled. They cannot read it. But this information is sent back to me, perhaps by email. Now, email is not very secure, so although I'll get this information, several other people could also get it. It could be hackers or whatever. It could be your email administrator. But in this public key system, the only way to decode the information is to use a private key. It cannot be decoded with a public key. So I keep the private key. I do not distribute that. But this private key can decode that information and bring back my plain text. So this is a second system which was invented based on two keys, one which is distributed publicly and one which has to be kept private. If it were ever distributed, your privacy would be compromised. Now, these public and private keys tend to be much larger in number than the symmetric keys. And we'll look at the implications of that in a bit. So they're very large. So some of this system you'll see is called PKI for Public Key Infrastructure. And we'll look at an example of how this works in more detail. So let's suppose we're here and we're on sort of a public network, okay? So our internet and all the communications here can be read by anyone. So we've got Dr. X here and Dr. Y here. And we've got Dr. Evil here. And we want to make sure of two things. We want to make sure Dr. Evil doesn't read any of our information. And we want to make sure Dr. Evil can't change any of that information. So let's suppose I know that Dr. Y wants to send me information. I'm here. So what I'm going to do is I'm going to send my public key out into the world. And Dr. Y will get my public key, but of course I can't prevent Dr. Evil from also getting my public key. Now, Dr. Y has a special message, so what Dr. Y does is Dr. Y will take my public key, because it's going to me, and take that information and he'll process it with the public key, and so what we get now is ciphertext. And that information is available to anyone. Dr. Evil can intercept that information, and I'll get that information. However, Dr. Evil doesn't have a private key for this ciphertext, so he can't read it and he can't change it. So what happens is I'll apply my key here to this information and get back my plain text that Dr. Y had intended to send to me. Now the same thing happens if Dr. Y wants to receive information from other people. The public key, is distributed to anyone on the internet. And so Dr. Evil can collect all the public keys that he wants, but he can't decrypt any of this information which comes, because the information which comes is all encrypted with a public key, but can only be decoded by the private key. So Dr. X wants to send information to Dr. Y. I'll take the plain text, we'll encrypt it, we'll send it here, and even if Dr. Evil can intercept that, he doesn't have Dr. Y's private key. So that system is used on the internet between people who are separated by a lot of geographic distance to get secure information back and forth. So we have these two systems. We have symmetric key encryption. This is called asymmetric key, as you may see this term. Encryption, or PKI, public key infrastructure. And so the terms that we're going to use here is this asymmetric key system uses a private and a public key, also called PKI, and it solves what we're going to talk about as a key distribution problem. So we'll look at that next. Now, most communication systems use symmetric key encryption. Well, why is that? Well, we talked previously about symmetric key using keys which are 128 to 256 bits. And to encrypt and decrypt is very fast. We looked at public key encryption. So this is symmetric key. Public key encryption uses a private and a public key, but the keys have to be very much larger, and this is just a mathematical reason, in order to get the same level of security. So here now, if I'm going to use PKI, they have to be 1024, 2048, and they're very slow. Well, that means that ideally we want to use symmetric key because I've got a lot of information I want to send and I want it encrypted very fast because I want to send it on the internet. Maybe I'm encrypting video information, which has a large bandwidth. So we want our encryption system to be as fast as possible. The problem is I'm over here in this geographic location. There's someone else in this geographic location. And how do I get a key to them so that we can use symmetric key? Well, this is where public key encryption or infrastructure comes into place. So, what happens is we'll use a public key infrastructure between two parties so that we get a symmetric key. Distribute it to both ends. So I've got a key here on both ends, and I'm going to use PKI to actually get the key to both ends. So now we've got the same key, and that was a pretty small amount of data that we had to send back and forth. And so even though this is slow, we can use this system to do that. Once we both have the same key, we can use symmetric key encryption to then encode all our future communications and send them back and forth very quickly and very efficiently. So all secure communications today use symmetric key. So whether we're talking SSL for our web pages, whether we're talking SSH, secure shell, where we were trying to administer maybe a Cisco router because we're an administrator, whether we're communicating with a VPN to our corporate network, they're all going to use symmetric key encryption, but at the beginning, when they're setting up this whole system, they're going to use public key encryption system as well. So both systems are used, but the public key is used at the beginning. The symmetric key is used for the bulk of the traffic going back and forth.